Hello, we're Group 6. I'm Joshua Mietzma, and with me are my compatriots Natalia Shu and Taha Nadim, and we're going to be talking about polyaromatic hydrocarbons with a focus on naphthalene. So the first thing we need to discuss, of course, is what are PAHs and naphthalene, where do we find them, and why should we care? So polyaromatic hydrocarbons, or PAHs, are a large group of aromatic hydrocarbons characterized by two or more benzene rings. They're generally made through incomplete combustion of hydrocarbon mixtures like crude oil or tar, and these combustion reactions for different fuels result in different pH proportions, but inconsistent ratios, which allows analysts to forensically determine the source of contaminating PAHs if there are multiple possible sources. And this family is of concern, as many of these compounds are carcinogenic or otherwise toxic to organisms, including mammals such as humans and aquatic life. They also tend to be strongly nonpolar and, as such, sorb very well to black carbon, such as soot, coke, or coal, which can reduce their bioavailability and toxicity in the environment. Now, naphthalene is the lightest of all PAHs with a molecular formula of C10H8, and you can see the structure on the slide here. As you can see, it's quite volatile at room temperature, it's largely insoluble in water, and poses some health risk to both humans and the environment, which I'll discuss in a moment. From the safety diamond, we can see that naphthalene is considered hazardous and also flammable above 100 degrees Celsius. Yes. Naphthalene is classified as a possible carcinogen based on animal studies and some case studies where exposure to PAH mixtures which included naphthalene did increase the risk of cancer, although to be certain if naphthalene itself is a cancer-causing substance, a carcinogen, more study would be required. However, acute exposure can cause hemolytic anemia, cataracts, liver damage, and in infants it can cause neurological damage. Naphthalene and several of its metabolites, such as 1,2-naphthoquinone and 1,4-naphthoquinone, are toxic to white blood cells as well. Naphthalene is also extremely toxic to aquatic life and has resulted in accidental and suicidal poisons through both ingestion and inhalation. As a result of all of this, naphthalene has been classified as a priority pollutant by the US EPA. Now, it's very rare to find naphthalene contamination in soils in isolation, as most industrial activities producing or using naphthalene involve many other organic chemicals, including other PAHs. Naphthalene is sometimes produced intentionally as a product, where it's used to produce phthalic anhydride, industrial dyes, plasticizers, synthetic resin celluloid, propellants, solvents, lubricants, or for use as a pesticide. More often, it's produced unintentionally by incomplete combustion of carbohydrate mixtures, such as crude oil or creosote, and it's often found at sites contaminated with coal tar or at coal tar refineries. It can also be found in ash from hazardous and municipal waste facilities. Creosote, which historically has been used for wood treatment and some other applications, is made mostly of naphthalene, so this can also be a potential source of naphthalene.
Next, we're going to talk about what happens to naphthalene when it is in the soil. Because naphthalene has a low solubility and high validity, naphthalene will volatilize from water to surface soils to the ambient air, and this volatilization rate will decrease with increasing depth. Naphthalene also has high mobility through sandy soils, and the transport in soils can be slowed down by sorption, which is dependent on the organic carbon content in the soil. Depending on the soil conditions present, naphthalene can be degraded in the soil. Under aerobic conditions, indigenous microorganisms will degrade naphthalene to carbon dioxide, and under anaerobic conditions, biodegradation will begin to decline, and this is because naphthalene will adsorb to the organic matter in the soil, which reduces the bioavailability for microorganisms, which will result in reduced biodegradability of PAHs.
Now we will look at some remediation technologies that we can use to clean up naphthalene contamination. Here's a quick glance of the 4 different technologies that we will be discussing in this video. The first treatment technology that we'll be looking at is double dielectric barrier discharge, or DDBD for short. This technology involves passing AC current through a reactor along with carrier gases such as oxygen and nitrogen to extract the contaminant. In this study, the reactor was able to extract roughly 97% of naphthalene after 30 minutes in the reactor at 40 kilovolts. This figure illustrates the general setup of a DDBD reactor used in the study. When it comes to advantages and disadvantages, even though a DDBD reactor is fast and highly efficient at removing contamination, it uses up electricity, which can raise major cost concerns and requires external sources of oxidants to operate. Similarly, even though it's a highly adaptable technology, a lot more research is required before it can be implemented on a large-scale application.
The second remediation technology we are going to talk about is the slurry phase bioreactor. This is an ex situ bioremediation technique that uses microorganisms to remediate contaminated soils. How this works is the contaminated soil is combined with water and any additives, and then it is put into a bioreactor. The advantage of this method is that when we use surfactants and solvents, we increase the availability of the contaminant to the bacteria, which will allow for faster treatment times. Since this is an ex situ technology, it is very easy to control and optimize any environmental parameters like temperature or pH. Any lab scale experiments that was done can also be quickly converted to full-scale processes for commercial and industrial applications. However, some of the limitations that comes with the slurry phase bioreactors is that it can be quite costly. And these costs are related to excavations, handling or transportation of contaminated soils, any pre-treatment prior to bioremediation that needs to be done, and just overall construction and operational costs. Another downside is that we also need to find an acceptable method for disposal of the wastewater that was not recycled throughout the process. And for industrial applications, most slurry phase bioreactors are batch-based and will not operate continuously.
Another treatment technology that we can use is hydroxypropyl cyclodextrin, or HPCD for short. Cyclodextrin compounds have the ability to solubilize low-polarity organic compounds such as naphthalene. In this study, inoculated bacteria and HPCD were added to soil samples that were artificially contaminated with naphthalene. Researchers found that the naphthalene degradation done by bacteria increased to twice the regular amount by using HPCD. Using HPCD is a simple and cost-effective way to get rid of naphthalene contamination. However, it's a slow process which involves using bacteria, therefore potential for secondary contamination to occur in certain cases, depending on site specification, is a possibility. Furthermore, the bacteria needs to be inoculated before adding HPCD.
The last remediation treatment technology we are going to be talking about is phytoremediation. This is an in situ technique using plants in combination with microorganisms to immobilize, remove, evaporate, and degrade contaminants in the soil. A study in particular used pea seedlings to remove up to 67% of naphthalene in the soil within a 3-week time period. And the study also concluded that there was no signs of phototoxicity in the duration of the pea seedling growth. One of the good things about phytoremediation is that it is cost-effective, eco-friendly, and non-invasive. It is also effective for a wide variety of contaminants with low to medium molecular weights. On the downside, phytoremediation can be a slow process and it might require multiple growing seasons. It is limited by the depth of the soil, and it should also be noted that low molecular PAHs, such as naphthalene, and other organic compounds like toluene, might be toxic to some plant species used, and therefore selection of the plants used in phytoremediation can become very important.
So we might ask ourselves, which is the best technology? Well, the answer depends on your situation. In case environmental agencies and regulators are strictly monitoring and pressuring for bioremediation, slurry bioreactors are a good option. However, non-thermal plasma solutions such as DDBD reactors are very promising if more extensive research and testing is done.
So now we'll just take a brief look at an Albertan example, which is the Domtar Wood Treatment Center here in Edmonton, which operated from 1924 to 1987, where they treated wood with creosote in order to preserve it. Unfortunately, waste was dumped untreated into a drainage ditch from this plant until 1972, where it contaminated both soil and groundwater. The land was then sold to a residential developer called Cherokee, who carried out a remediation plan, and a remediation certificate was granted by Alberta Environment for a section of this land in 2013. Unfortunately, sampling in 2017 and 2018 showed unacceptable levels of naphthalene as well as several other compounds. Even more unfortunately, houses had already been sold in the area at this time. Because of this, a timeline for development of a new remediation plan was set by the Minister of Environment in 2019, requiring action by both Domtar and Cherokee, and these plans are now under review by the Alberta Environment. And this is just an example very close to home of where naphthalene contamination might take place.
And now for a quick overview. Naphthalene is a volatile PAH. It is classified as a primary pollutant by the US EPA. Naphthalene is produced from incomplete combustion and it can be found in carbohydrate mixtures. When naphthalene is in the soil, it will volatilize from water bodies to surface soils to the ambient air, and it can be degraded in aerobic soil conditions. Depending on the situation present, the best treatment technology for naphthalene is the slurry phase bioreactors or the double dielectric barrier discharge. In relation to Alberta, there was a case of naphthalene contamination from creosote in northern Edmonton by the Domtar company, and currently new remediation plans are under review.
Here's a list of references that were used in this presentation. And that is the end of our video. If you have any questions, please feel free to email us at any of the email addresses provided. Thanks for watching.